Example M7.3, a 1,800 kilogram car stopped at a traffic light and is struck from the rear by a 900 kilogram car. The two cars become entangled, meaning they get stuck together, moving along the same path as that of the originally moving car. So A, if the smaller car were moving at 20 meters per second before the collision, what is the velocity of the entangled cars after the collision? And B, suppose we reverse the masses of the cars. What if a stationary 900 kilogram car is struck by a moving 1,800 kilogram car? Is the final speed the same as before? Okay, so the best thing to do here is to visualize the car. Okay, so we will use particles for that for now. Okay, so we have a red particle and a blue particle. Okay, so say this is the 1,800 kilogram car, and then this one is the 900 kilogram car. Okay, so it strikes the red particle from behind. Okay, so let me copy that. It strikes the red particle, and then they become entangled, right? And then they move together in the direction of the originally moving car. Okay, so if this car or this particle is going here, then the velocity would be going there as well. Okay, now we see that this is a perfectly inelastic collision. Okay, and therefore by applying the conservation of momentum equation, then we will be able to determine the velocity of the entangled cars after collision. Okay, so the initial momentum should be equal to the final momentum, right? Because of the conservation of momentum. All right, so we have 900. Okay, 900 kilograms times 20. Okay, and plus 0. This will account for the momentum of the 1,800 kilogram car. Initial momentum. But since it's at rest, that means there is no momentum. Okay, so it's 0. And therefore we have 900 kilograms times 20 equals 900 plus 1,800 times VF. And therefore we can solve for VF, and VF will be 6.67. Now if we reverse the cars, the masses of the cars, it's the same thing. We will just apply the same formula, only that for M1 we will be using 1,800, and for M2 we'll be using 900. Okay, so solving that, we will have a VF of 13.3 meters per second, which is substantially higher. It's double in size from part A. Okay, so the larger the mass that hits the car, okay, the faster it goes when it becomes entangled.